So welcome back everyone after the coffee break for our second half of the panel. Our next speaker is Ruben, no introduction needed, and you'll be speaking about the Greek Astro-Meteorological calendars. So please go ahead. Thank you.
Thanks very much. So actually I was just talking with Hans very briefly about how we have these theoretical approaches represented by his talk, and then we have Anton's approach looking at the archaeological and scientific data. And part of the goal of this paper is to, in some way, marry those two approaches. So the more textual approach to thinking about, in this case, weather, and then some of the scientific evidence and how these specific texts, these weather calendars, can be used to think about perhaps resilience in relation to climate change in the first millennium BC Greek world. Interest in pre-modern climate change has exploded in the 21st century, and our understanding of the climate history of the ancient Aegean world has improved rapidly over the last 2 decades. Nonetheless, ancient historians have been relatively slow to grapple with the challenge of how to integrate evidence for climate change into their historiography. Scholars studying climate-society interactions between the medieval and early modern periods have been more active in this realm, and many have begun to refine the methodologies of and set the research agenda for pre-modern climate history. A topic of interest that has emerged in this discussion is the importance of reconstructing the cultural frameworks that govern perceptions of weather in pre-modern societies in order to understand responses to the effects of climate change at the level of the household, the community, and the state. In this paper, I'll discuss one aspect of the perception of weather in ancient Greece, the development of systems of astrometeorological observation and weather forecasting, and what purpose they may have served in decision-making within the late classical and Hellenistic polis. Between the 5th and 1st centuries BC, astrometeorological calendars that claimed to be able to forecast shifts in the weather to the week or even the day, known as parapegmata, proliferated. By the end of the Hellenistic period, these had come to be used throughout the Greek world, including by polis that published their own such calendars. But while the scientific context of this development has been much discussed in scholarship, there has been relatively little reflection on who may have used these documents and why. In this paper, I argue 3 points in relation to this development. So first, by the 2nd century BC, a variety of parapegmata attributed to different scientific authorities and produced in various regions of the Greek world were circulating. And individuals or communities combined different examples to produce their own astrometeorological calendars. Second, the widespread adoption of such detailed documents fundamentally shifted the perception of meteorological norms among at least the literate elite, as the creators of parapegmata claimed to have used empirical means to determine normal weather patterns with precision. And third, while these rigid meteorological schemes could of course never have accurately predicted stochastic weather patterns, they were of interest to polis because the organization of collective responses to irregular weather or extreme weather fell predominantly to civic governments. And these calendars were regarded as authoritative tools for monitoring and anticipating meteorological shifts. In the Greek world, traditions of weather observation and prognostication are first attested in Hesiod's works and days, which used astronomical markers, simple day counts, and natural omens to anticipate agriculturally significant meteorological developments. The foundation of this tradition was the belief that just as the revolutions of celestial bodies could be observed and predicted, so too could be environmental developments with which they were correlated. Over time, this led to the development of increasingly elaborate predictive astrometeorological models, some of the earliest and most detailed of which come from the Hippocratic corpus. Because in Greek thought, health was believed to be directly linked to atmospheric conditions, physicians, by the 5th century BC already, were keenly interested in understanding weather patterns. References in works such as Airs, Waters, Places, and The Epidemics indicate that by the late 5th century BC, it was the norm for physicians to keep relatively detailed records of atmospheric phenomena, which they judged against normal seasonal weather patterns in order to anticipate the appearance of particular illnesses among a population. And so this is from the first case study in the epidemics from Thasos. So we have this detailed record. We don't know what year it dates to, probably sometime in the mid-5th century BC. There's been an argument for earlier dating now from Ruben and Fox for the epidemics. But nonetheless, it's remarkable for the detail it records about seasonal weather patterns in this one particular year. But these preserved meteorological assessments are merely qualitative, and no clear method is provided for establishing when a season or year's conditions transgress climatic norms. Around that same time, so around the late 5th century BC or mid-5th century BC, some Greek astronomers then began through meticulous observation to produce more detailed astrometeorological calendars used to predict correlated sidereal and atmospheric phenomena known as parapegmata. As the name, which is derived from the verb parapegmai, to insert something beside, implies, parapegmata were originally physical documents that allowed for the precise tracking of observed phenomena using pegs inserted into holes. And this is the best preserved epigraphical example. And you can see the holes, you put a peg in, and every day you can move it one more slot along and track what was going on around you, according to the document. Over time, these documents came also to circulate in a literary form. The prototypes of these calendars were those of the late 5th century BC Athenian astronomers Meton and Euctemon, the former of whom famously postulated a 19-year cycle of astronomical revolutions that was believed to determine weather patterns. So Meton and Euctemon's attempts to systematize astrometeorological patterns signal a shift not only towards the creation of empirically based meteorological schemes, allowing for the comparison of current weather patterns to normal or normative weather patterns, but also detailed means of forecasting meteorological developments. Between the 4th and 1st centuries BC, numerous astronomical authorities produced their own parapegmata, which proliferated throughout the Greek world and grew increasingly sophisticated, many claiming to be able to predict weather patterns on a weekly or even daily basis. Between fragmentary inscribed examples and those preserved in the literary tradition, we know of about 60 such calendars from this period, with some authorities such as the 4th century BC Eudoxus of Cnidos, the early 2nd century BC Hipparchus of Rhodes, achieving particular renown for theirs. It should be noted that probably the most famous author of one of these is Julius Caesar, who produced one himself in the 1st century BC, but the majority of the authors who are preserved, even in the later Roman versions, such as Ptolemy's compilation, almost all of them are Greek, and almost all of them date to between the 4th and 2nd centuries BC. We are luckily well informed about this development, in large part due to the preservation of the astronomer Geminus of Rhodes' early 1st century BC treatise, The Introduction to the Phenomena, that's Aratus's Phenomena, which not only included a detailed astrometeorological calendar compiled from several authoritative parapegmata, but also a lengthy chapter reflecting on the use of these documents. In this chapter, Geminus describes the process by which these calendars were composed. So he writes, astronomers took the beginning of the year, and having observed in which zodiac sign the sun started at the beginning of the year, they recorded against the degree of each sign, day by day and month by month, the important changes that occurred in the air, winds, rains, and hail, and they placed these beside the positions of the sun, reckoned by sign and by degree. Having observed these things for more years, they recorded in the parapegmata the changes that occur, for the most part, around the same places of the zodiac. By the time the astronomer Ptolemy set out in the 2nd century AD to compile an even more comprehensive list of weather predictions than Geminus's, he was able to gather almost 1,000, so an average of 2.5 per calendar day. Crucially, there is reason to believe that these and related meteorological texts were read by a relatively broad swath of literate Greek elites. Geminus, for instance, laments the fact that the popularity of parapegmata had produced among laymen, so paramentois idiotais, a widespread belief that celestial phenomena were not only correlated with changes in weather, but that they actually directly caused them. So he complains that people say, oh, the dog star, you know, in late summer it rises, it gets very hot, and then people say, oh, the dog star is the reason it gets hot, that somehow the star actually causes the heat that everybody experiences in late summer. So he's got this kind of long diatribe where he talks about this problem that he sees. Columella, in the 1st century AD, discusses parapegmata quite a bit, and he also states that he even felt compelled to write a treatise called Against the Astronomers, attacking the use of parapegmata and the belief that, quote, changes in the air coincide with fixed dates as if they were confined within certain bounds, unquote. The popularity of astrometeorological prognostication is also reflected in the enormous success of Aratus of Soloi's 3rd century BC treatise, The Phenomena, which integrated elements of the parapegma tradition into a didactic poem that became hugely popular soon after its publication. And I mean, The Phenomena was probably one of the most read texts by the late Hellenistic and early Roman period. It was phenomenally popular. And actually it had become an educational text already by the time we get to sort of the late Hellenistic period, it seems. There is also scattered evidence suggesting that parapegmata were compiled and erected by late classical and Hellenistic polis as inscriptions. And so I already showed you that one example. It's by far the best preserved example that we have. I'll talk about it more in a minute. Scholion to Aratus's Phenomena, referring to Meton's 5th century BC astrometeorological calendar, sheds some light on this practice. So he writes, those astronomers who came after him, Meton, set up plaques, pinakas, in cities with regard to the 19-year revolutions of the sun, having reckoned that in each year there would be such a kind of winter, summer, autumn winds, many other things useful for people's everyday lives. Since these things are known from the plaques, and Aratus himself knew all of this from them, Aratus was writing in the 3rd century BC, and then he goes on to comment on this passage of the phenomena. Diodorus, in the 1st century BC, also notes of Meton's astrometeorological calendar that, as he notes here, the stars produce both their movement and the changes they signal, episemasias, and this is a technical term that refers to signs or omens that indicate weather changes. So he's specifically referring to weather with this term here. That the changes they signal in accordance with his and Meton's reckoning. Consequently, down to our own day, the majority of the Greeks employ the 19-year cycle and are not cheated of the truth. So the only relatively well-preserved inscribed parapegma from the Greek world comes from the theater of Miletus. It was found in situ in the wall of the theater, comprising 3 fragments from a monumental example that has been dated by an archon date to 89-88 BC. And this includes numerous references to weather as well as astronomical changes. Importantly, the form of this calendar is very similar to preserved literary parapegmata, even if some of the authorities cited are otherwise unattested. So this is clearly a local calendar. The Calaneus, this Indian figure, is not otherwise attested as a source for a parapegmata, for instance. So this evidence prompts 2 questions. First, who used these calendars? And second, what purpose or purposes did they serve? The publication of parapegmata by polis suggests that civic governments wished to subsume these calendars under their own authority and that they were intended to be of some use to their communities. Several scholars have argued that these were used to link the sidereal calendars of the agricultural world with the lunar calendars of polis, which often became infamously misaligned over time, in order to create a unified chronological framework for all the inhabitants of these city-states. This was undoubtedly one reason why parapegmata were useful, but this does not account for the inclusion of meteorological phenomena in these documents. Some scholars have thus assumed that they were used by farmers and sailors, groups to which Greek meteorological literature sometimes refers. But few individuals in these professions were likely to have been literate enough to have been able to make use of these texts. Certainly wealthy Greek farmers, I'm sure, would have used them, but many others probably would not have. And monumental examples erected in urban centers would, at any rate, mostly have been of little quotidian use for those working the fields or sailing the seas. I argue that parapegmata came to be viewed by Greek civic officials as symbolic instruments of authority, useful for managing the impacts of abnormal weather on agriculture and the food supply, amongst other things. So another element of this project, I looked at the medical impacts of public physicians, what use public physicians in the Hellenistic world could have made of these documents. But I'm today just focusing on agriculture and the food supply. As we have seen, these documents attempted to establish normal meteorological patterns using empirical observation. But as a passage in Polybius of the mid-2nd century BC illustrates, unusual weather phenomena required a different kind of response. So he writes, this is in an aside on a passage about Greece in the mid-2nd century BC. He says, with regard to phenomena whose causes it is impossible or difficult for a human to understand, we may perhaps be justified in getting out of the difficulty by ascribing them to the action of a god or a chance. I mean such things as exceptionally heavy and continuous rain or snow, or the destruction of crops by drought or frost, or a persistent outbreak of plague, or other similar things whose cause is not easy to detect. With regard to such matters, we naturally follow the beliefs of the majority, as we cannot make out why they happen, and attempting by prayer and sacrifice to appease the divine, we send to ask the gods what we must do and say to set things right and cause the evils that afflict us to cease. So in this passage, Polybius makes clear that hoi polloi ascribed abnormal weather, or extreme weather, to divine displeasure, a common belief attested in numerous ancient texts, most famously Aristophanes' clouds. This indicates that if parapegmata reflected an empirical understanding of meteorological norms, then significant deviation from those norms transitioned from the realm of the rational into the realm of what anthropologists have termed moral ecology, in which environmental phenomena were viewed as manifestations of divine will that demanded collective religious action. Some evidence relating to Greek oracles lends support to Polybius' statement that oracular inquiries related to weather, agriculture, and public health were among the most important made by polis. Plutarch, in a discussion of the oracle at Delphi, states that in his day, quote, the majority of inquiries of polis concerned the yields of crops, the propagation of livestock, and the health of somaton, so either bodies or slaves. It's ambiguous, I think, the meaning here. This is largely borne out by preserved inquiries from Dodona in central Greece. Of the 4,200 published oracular inquiries dating to between the mid-6th and the mid-2nd century BC, 17, so 1-7, were made by communities, the remainder by individuals. While almost every aspect of life is referenced in these inquiries, extremely few private inquiries relate to weather, the harvest, or collective health. By contrast, of the community inquiries, 2 reference these topics, and I listed them here. So one, a late 4th century BC collective consultation of the Kerkerians and the Orikians asks to which deities they should sacrifice so that, quote, there may be fine and abundant harvests for them and the profit of their entire good crop, unquote. And the second, 4th to 3rd century BC inquiry of the polis of Dodona itself, so these are locals going to their own oracle, asks whether it is, quote, because of the impurity of some man that a god is sending the storm or the wintry weather. Hemona here is ambiguous as well. Thus, weather and its broad impacts on the agriculture or health of a community was an active concern for Greek civic governments. Communities throughout the Greek world became increasingly concerned with managing the food supply of the staple grain crops of wheat and barley available to their inhabitants from the classical period onward. By the 4th century BC, monitoring the agricultural economy and intervening when necessary to subsidize and or obtain and distribute public stocks of grain was viewed as one of the primary focuses of civic officials. To understand the role that parapegmata might have played in such government intervention, it is necessary to consider the agricultural cycle in ancient Greece. So this is very schematic, but just for illustrative purposes. So generally speaking, Greek households, of course, had to rely on staple crops they collected and stored at harvest time for subsistence until the following harvest. I think generally speaking, the majority of Greeks, as we said, sort of outside of Athens and a few other big cities, probably this was the rule that they had to rely on at least their own production for the majority of their subsistence. Generally speaking, as these stocks then diminished throughout the year after the harvest, the price of grain generally increased, so that a shortfall in agricultural production would have been felt most acutely in the winter and spring months, immediately prior to the next harvest. As Greek farmers knew well, droughts, heavy rainfall, and cold spells during the growing season can all have deleterious effects on cereal yields. In many cases, traditional risk buffering mechanisms, particularly the sowing of late emergency crops such as millet, could have helped to mitigate the impact of such effects. But extreme weather that occurred in the spring could signal impending harvest failures at a time when it was too late for farmers to adapt. Households could generally endure a poor harvest so long as the next was sufficient. But if many households experienced an agricultural deficit simultaneously, and especially if it became apparent that the coming harvest was probably also going to be poor, then a localized food shortage could follow. For officials charged with intervening in the food supply, observation and timing were crucial. As Xenophon relates in his Memorabilia, one of the chief duties of the Greek politician was to monitor closely the grain supply, quote, so that you might not fail to notice when the polis is short of grain, but recognizing it, you may come to the rescue and save the city by giving essential advice in relation to the food supply. Two considerations were of paramount importance in this regard. First, if a polis was facing a food shortage during the growing season, officials might attempt to obtain grain supplies locally, often by appealing to wealthy landowners to donate or sell at a reasonable price their stored surplus grain. If the state possessed access to its own grain stocks, officials then had to consider when to begin distributing these supplies to the populace. Some detailed inscriptions relating to grain funds included clauses restricting the timing of public grain distribution. So for instance, the well-known Athenian grain tax law of 374-373 BC required that Athens import grain when it was cheap in the summer months, but banned its sale before the month of Anthesterion in February or March. A second consideration was that if local or regional grain supplies proved insufficient, civic officials needed to consider when it was necessary to send out commissioners to try to obtain grain from overseas markets, whether it was subsidized or was being bought by the polis itself. They needed to secure overseas markets when there was generally a localized food shortage. For the inhabitants of the Hellenistic Aegean world, among the most crucial such markets were Egypt and Cyrenaica, whose earliest harvest usually began in April, or sometimes even late March, a month or more before the beginning of the harvest in Greece. It should be noted that the Black Sea harvest is a month after that of Greece, so you have these staggered harvests that can come in from different parts of the Eastern Mediterranean world. It was often difficult, however, to ship goods safely by sea before the traditional opening of the sailing season in May. And if in times of regional grain shortage, communities had to compete with one another to obtain grain imports, the longer authorities waited to find suitable supplies, the higher the chance that foreign markets might be monopolized by other buyers. Furthermore, if officials chose to wait until the summer months and foreign grain supplies, such as from the Black Sea, proved limited, then prices could become prohibitively high. So this could be a very risky sort of gamble to take if you were a civic official. This meant that for officials faced with a local or regional food shortage and the prospect of an imminent poor harvest, there was a crucial window between late April and early June when they could have sailed safely overseas to attempt to secure early grain imports while they were still reasonably priced, and before the risk of having to compete too much and prices going up became a reality. In this respect, it's of interest that entries in the preserved parapegmata of Geminus and Ptolemy often mention meteorological phenomena such as rain and hail, but it has largely escaped notice that the frequency of references to these phenomena largely does not match attested weather patterns. So I've highlighted here in a few places, just for the period from March 25th to April 20th, in Geminus's parapegma, Some references to rain, hail, snow, storms, various meteorological phenomena. For example, one of the most cited authorities in both Geminus and Ptolemy's calendars is the 4th century BC astronomer Eudoxus, who, according to Ptolemy, made his weather observations in Asia, Sicily, and Italy. By Ptolemy's reckoning, Eudoxus includes more references to rain in April and May, so he includes 8 references in April and 4 in May, than in any other months, with more than twice as many references to rain in April as in December. And if anybody's familiar with the Mediterranean climate, there's much more rain, of course, in December or January than there is in April or May. So this is clearly a distorted representation of actual weather patterns. Furthermore, the only references to hail in the parapegma of Geminus occur in April and early May, while in the Mediterranean today, hail is in fact more common in late May, June, and July than in those months. In the Aegean, April and May, however, marked the last 2 months of cereal growth prior to the harvest. And as Paul Halstead's ethnographic work around the Mediterranean has shown, these months continue to be a period of anxiety for farmers in Greece even today. Cereals benefit immensely from repeated gentle rainfall in these spring months, which produces rapid growth. So Halstead records a saying of a Greek farmer from Messenia that, quote, wheat puts on 1 straw node in 5 months, between November and March, and then 5 straw nodes in 1 month, that is April. But too much rain can make cereals vulnerable to lodging, which is the bending of stems, which impairs development and can reduce or spoil the harvest. Furthermore, hail can cause significant damage to ripe cereals across broad areas. April, and to a lesser extent May, were also crucially the last months in which late sowing of cereals was possible, and sprouting plants were similarly vulnerable to heavy rainfall and hail. Thus, the references to rain and hail, at least, in preserved parapegmata suggest that these entries largely reflected concerns related to agriculture, in particular, the necessity for observation in the crucial spring months rather than actual weather patterns. So these aren't just empirical, objective records of the weather that was observed, but rather they're clearly being curated for specific purposes. As calendars that map the astronomical and meteorological developments of each year, parapegmata served an important symbolic purpose. These instruments conveyed an authoritative understanding of the natural world, being manifestations of the diligent surveillance of the heavens undertaken by some of the most renowned Greek scientific authorities. For civic officials, who were by necessity for the most part required to be literate and keen to recognize when the effects of weather on their communities demanded timely action, parapegmata would have provided a means of anticipating crucial windows of opportunity and building consensus for communal action. Many polis territories were broad, and their populations were scattered throughout the countryside, and officials thus largely would not have been able to monitor agriculture directly. These instruments could have shifted the basis of polis decision-making in relation to the food supply from the subjective experience of environmental phenomena to seemingly objective tracking and forecasting. By externalizing the evaluation of meteorological patterns, these calendars thus conferred on civic officials greater authority to determine when weather had progressed from being normal to abnormal, and when interventions were necessary, whether appealing to local landowners to donate surplus grain, releasing public grain stocks, sailing to purchase grain from overseas markets, or inquiring of an oracle what religious actions had to be taken to appease the gods. Thank you.